quick, let me get a show of hands. How many people said A?
I just got back from my doctor's appointment.
Real quick. How many people said A? The speed increases and the acceleration decreases. Nobody. B, its speed decreases and acceleration increases. Okay, we got one. C, both of them increase. Okay, looks like probably majority there. Both remain constant. D. Okay, a couple of us. Both decrease. Nobody. All right. Both decrease. E. So, real quick, let me get some rationale for one person that said C. That both increase. Let me get some rationale from somebody. Who said C? Yeah.
Because if it's going down the hill or whatever, then it's like accelerating and speed's picking up, and it's gonna keep on going.
So as it goes down the hill, the speed's picking up, so it's accelerating, and it's continuing to accelerate, right? Okay, so is that the majority of that rationale is sort of the speed's increasing, so therefore the acceleration's increasing? Yeah. Right? All right, so real quick, let me try and help you guys out here, because it turns out that none of us said the right answer.
Well, what's the right answer?
What was it? You say none of us?
Nobody got it right.
What was it?
So let's take a look. Let's take a look.
No, I want to tell me first.
Let's take a look.
You cheated.
So, real quick, I've got this ball rolls down the hill, right? So let me ask you.
Speed increases and its acceleration decreases.
Hang on. So,
I said
real quick, if I divide this up into three pieces, if I were to connect those pieces, would it look like that? That curve, right? If I connect these, does that make sense? Okay. So if I've got three segments here, and I send the ball down this one, what happens to the speed? It increases. Is it, so speed increases. What happens to the acceleration? Well, let's just say, is the acceleration a lot or a little?
A little of a lot. A little
A
of
little of a lot. All right, so explain what you mean by that.
Telling me.
Yeah,
I can't.
can't tell me. All right, so can anybody tell me what their rationale is behind whether it's big or small acceleration? You think it's big. Why do you say that? Okay, so does it have anything to do with maybe how steep it is?
I think the angle off the ramp is just too
How steep it is? The angle of the ramp?
Yeah, I think it's just
So-
too awkward.
If this is really steep, right, that speed is going to increase and increase, so it's a pretty big acceleration, right? So let's say, I'm just going to say the acceleration is high, right? So let's look at this next one. What's happening to the speed? Increasing or decreasing? Well, just for this segment right here. So the ball starts at this point, ends at this point. Does the speed increase or decrease? Is it speed up or slow? It's still going down, right? It's going to speed up, right? So speed is still increasing. What about acceleration? Is it more? Is it high, medium, or low?
Medium.
Right? Why do you say it's medium?
Oh.
Well, you say it's because it's in the middle, but what's different about this line versus this line?
The slope.
The slope, right? So the change in speed is going to be less from this point to this point than it was from this point to this point. Do you guys see that? The change in speed, right? Let's think about this. The change in speed for this segment is going to be pretty high, right? It's accelerating a lot. Whereas this segment, the change in speed, right? It's less of an incline, so it doesn't speed up quite as fast, right? It's the rate of change of how the speed changes, right? A lot of words in there. I know it's a little bit confusing, but let's take a look at this bottom one again. Right? Down at the bottom is the speed. What's the speed doing?
Decreasing.
Speed's decreasing. Why do you say that?
The slope and the angle.
Okay, so am I still angled down?
Yeah, but
I think it's
So if I have a ball on a ramp and I drop that ball, does that ramp cause it to slow down or speed up?
speed it up.
Usually it speeds up, right? It accelerates down the ramp. So anything falling, right, down the ramp is going to accelerate. So speed is still going up. But does it speed up? If I've got a ramp like this and I roll a ball down, does it take longer to go down than if I've got a ramp like this?
yep.
Yeah, so what does that mean about the rate of change of the speed? It's not much, right? It doesn't change much over that given time versus here, I've got a lot less time to go. So it's changing a lot. So up here, the speed changes a lot from here to here. But once it gets to this point, from here to here, how does the speed change?
It slows
Compared
down,
to
it's
that
more
one.
constant. Slows down, it's more
It's-
constant.
Yeah, it slows down based on the acceleration, right? You said the acceleration is less, right? Because the slope of this is less, right? So it's not changing quite as much. So if I say acceleration is low, right? Because it's not changing quite as much, what does that tell you about the speed and acceleration and how they relate? You guys, most of you said C, right?
Yeah.
Both of them increase.
I say A.
So you said, what was A again?